question of exercise 11.4. So it is evaluate the following things. So evaluate the following bits. So let's consider the first one. We have 1 plus tan theta plus secant theta into 1 minus cot theta minus cosecant theta. So first I'm going to convert these into sine and cos, and also I will consider the denominators of this 1 as 1. So this would be the same, nothing would change. So tan theta would be sin theta by cos theta, and secant theta would be 1 by cos theta. And this again 1 by 1. Cot theta is cos theta by sin theta, and minus 1 by sin theta. I would take the LCM of these two. So LCM of the first one will be cos theta. So after LCM we would get, this would be cos theta plus sin theta plus 1 whole by cos theta. And the second term LCM is sin theta. So this would be sin theta plus cos theta minus 1 by sin theta. Let's consider this cos theta plus sin theta as A and 1 as B. You can see here A plus B into A minus B, and A plus B into A minus would be A square minus B square. So this would be sin theta plus cos theta square minus 1 square, and denominator it would be sin theta into cos theta. And let's expand the numerator, the A plus B whole square. So this would be A square plus B square plus 2AB, 2 into sin theta into cos theta, and minus 1 square is 1, and denominator we have sin theta into cos theta. So we know that sin square theta plus cos square theta is equal to 1. So 1 plus 2 sin theta into cos theta minus 1 by 2 sin theta cos theta. Sorry, we don't have 2 in the denominator. Sin theta into cos theta. This plus and minus 1 will be 0, and we have 2 sin theta by cos theta. Sorry, 2 sin theta cos theta by sin theta into cos theta. This sin and cos will get cancelled, and the answer we are left with is 2. So initially we changed the tan, secant, cot and cosecant into sin and cos. So tan is sin by cos, secant is 1 by cos, cot is cos by sin, and cosecant is 1 by sin. I have taken the LCM in both of these terms and grouped them, this A plus B into A minus B as A square minus B square. If you're not understanding this step, we can directly multiply all the terms with each other. So let's see that this sin cos theta into sin theta will be, let's write it here, sin theta into cos theta. Next we have cos theta into cos theta, we have cos square theta. Then we have cos theta into minus 1 is minus cos theta. Then sin multiplied with sin is plus sin square theta, and plus sin into cos is sin theta into cos theta, and sin theta into minus 1 is minus sin theta, and then we have 1 into sin theta, 1 into cos theta, and 1 into minus 1. So that would be sin theta plus cos theta into minus 1. So we can see that this minus sin plus sin theta is cancelled, minus cos and plus cos will get cancelled, and what did we get eventually? We got sin square theta plus cos square theta plus 2 sin theta cos theta and minus 1. That is exact same thing which you got in this step, right? Sin square theta plus cos square theta plus 2 sin theta cos theta minus 1. And next sin square theta plus cos square theta equal to 1. and 1 minus 1 is 0, and therefore 2 sin theta cos theta by sin theta cos theta we get as answer is 2. Now let's say the second bit. Second bit we have sin theta plus cos theta whole square plus sin theta minus cos theta whole square. So let's see the question. Sin theta plus cos theta whole square plus sin theta minus cos theta whole square. So simply let's expand the both of them, like a plus b whole square. This would be sin square theta plus cos square theta to sin theta cos theta. And this would be a minus b whole square. So this would be sin square theta plus cos square theta minus 2 sin theta cos theta. So this minus and plus will get cancelled. This is equal to 1 and this is equal to 1. Sin square theta plus cos square theta equal to 1. So 1 plus 1 is equal to 2. That's it. Next, last one, third one. Let's see the one. So we have secant square theta minus 1 into cosecant square theta minus 1. We know that first initially secant square theta minus 1 is tan square theta and cosecant square theta minus 1 is cot square theta, because we know that. Let's write the since here. Secant square A minus tan square A equal to 1, and then other one is cosecant square A minus cot square A is equal to 1. So from these two formulas, secant square theta minus 1 is equal to tan square theta and cosecant square theta minus 1 equal to cot theta. And tan and cot are reciprocal to each other. So this would be cot square theta would be 1 by tan square theta. This both will get cancelled and the answer we get is 1. So after evaluation, we got the first answer as 2, second bit answer is also 2, and the third bit answer is 1. Second question of exercise 11.4. So you have to show that cosecant theta minus cot theta square is equal to 1 minus cos by 1 plus cos. So let's consider LHS part. So LHS we have cosecant theta minus cot theta whole square. So I'm going to write cosecant and cot in terms of sine and cos. So cosecant will be 1 by sin theta by cos theta by sin theta. Cot theta equal to cos by sin. So we have this. And since sin theta is the LCM here, this would be 1 minus cos theta by sin theta whole square. This square will be applied for both numerator and denominator. So this will be 1 minus cos theta square by sin square theta. We know that sin square theta plus cos square theta equal to 1. And that is why I'm going to substitute sin square theta is equal to, so I'm going to write it again. Okay. So 1 minus cos theta whole square. And I'm going to substitute sin square theta equal to 1 minus cos square theta, since sin square theta plus cos square theta is equal to 1. And if I take the sin cos square theta to the left hand side, sin square theta equal to 1 minus cos square theta. And next we have, I'm going to expand the numerator. Okay. Or since it is square, I can simply write it as 1 minus cos theta into 1 minus cos theta. We can write a square as a into a. Similarly, 1 minus cos theta whole square is equal to 1 minus cos theta into 1 minus cos theta. And if we observe the denominator, I can write this 1 as 1 square, and 1 square minus cos square theta. It looks like something like a square minus b square, and we know a square minus b square equal to a plus b into a minus b. Therefore, 1 square minus cos square theta can be written as 1 plus cos theta into 1 minus cos theta. So what I have done, I have substituted 1 minus cos square theta in the place of sin square theta in the denominator, and then in the numerator we have 1 minus cos square, 1 minus cos theta whole square, and I have written it individually, like since a square can be written as a into a, similarly 1 minus cos theta whole square I wrote as 1 minus cos theta into 1 minus cos theta, and denominator there is 1 minus cos square theta, and I wrote 1 minus cos square theta as 1 square minus cos square theta, so that I can divide them as 1 plus cos theta into 1 minus cos theta by a square minus b square formula. So it would be a plus b into a minus b. The 1 minus cos theta and in the numerator denominator will get cancelled, and eventually we got it as 1 minus cos theta by 1 plus cos theta, which is actually the RHS just given in the question. So when we took the LHS, we took the LHS, which is cosecant theta minus cos theta cot theta whole square. I have replaced them with sine and cos of their equivalent. So cosecant theta is 1 by sine theta, and cot theta is cot theta cos theta by sine theta. So I took the LCM. I have taken the squares on both numerator and denominator. I have divided them individually and calculated them out in the last step. Third question of exercise 11.4. So we have to show that under root 1 plus sine theta by 1 minus sine theta is equal to secant A plus tan A. So let's first consider the left hand side of the part. So LHS we have under root 1 plus sine A by 1 minus sine A. So what I'm going to do here is I'm going to multiply 1 plus sine A in the numerator and the denominator. So let's take a long root here. The 1 plus sine A is the same, and this is also same. I'm going to multiply 1 plus sine A in the numerator and also in the denominator. So 1 plus in the numerator it is 1 plus sine A whole square. It is 1 plus sine A whole square. But in the denominator it is a plus b into a minus b, which is a square minus b square, is 1 minus sine square A. So 1 square is 1 and sine square A is sine square. So numerator we have 1 plus sine A whole square, and in the denominator we have 1 minus sine A square. So we know that 1 minus sine theta, 1 minus sine square theta is equal to cos square theta. So this would be 1 plus sine A whole square cos square A. And the square and root will get cancelled. So this root, this and this square will get cancelled, and we are left with 1 plus sine A by cos A. And I can divide the denominator with both of the numerators. So both terms of the numerator. So this would be 1 by cos A plus sine A by cos A. And the reciprocal of cos theta is secant theta. So 1 by cos A is equal to secant A, and sin theta by cos theta equal to tan theta. That's it. This is the RHS side. Fourth question of exercise 11.4, we have to show that 1 minus tan square A by cot square A minus 1 is equal to tan square A. And theta is an acute angle. It is lies between 0 and 90 degrees. So let's consider the LHS part of the question first. So LHS we have 1 minus tan square A by cot square A minus 1. So now in this LHS part, I am going to substitute the reciprocal of cot A in the denominator. We know that cot A is equal to 1 by tan A. Therefore, cot square A is equal to 1 by tan square A. So this would be 1 minus tan²A by 1 by tan²A minus 1. So in the denominator, I'm going to take LCM. So this would be 1 minus tan²A in the numerator, and the LCM would be tan²A. So 1 minus tan²A by area. And if we get confused like this, we can write like 1 minus tan²A divided by 1 minus tan²A by tan²A. And if I change the division symbol to multiplication symbol, I have to reciprocal the second term. So this would be 1 minus tan²A multiplied by tan²A by 1 minus tan²A. So this 1 minus tan²A and 1 minus tan²A would get cancelled, and we are left with tan²A, which is the RHS part of the question. So the fifth question of exercise 11.4, and the question says that show that 1 minus cos theta by cos theta is equal to tan theta into sin theta if theta is between 0 and 90 degrees. So if theta is an acute angle, show that 1 by cos theta minus cos theta equal tan theta into sin theta. So let's initially consider the LHS part. LHS is equal to 1 by cos theta by minus, sorry, we don't have square in the denominator, 1 by cos theta minus cos theta. So if I take the LCM, it would be 1 minus cos square theta by cos theta. We can see that the 1 minus cos square theta is equal to sin square theta because sin square theta plus cos square theta equal to 1. Therefore, sin square theta equal to 1 minus cos square theta. So I can substitute here. Next, this would be cos theta. I am going to write sin square theta as sin theta into sin theta. So this would be sin theta into sin theta by cos theta. And since the terms in the numerator are in multiplication and not in addition, I can only give the denominator to one of the terms of the numerator. So this would be sin theta by cos theta into sin theta. And we know that sin theta by cos theta equal to tan theta, and this is the what they gave in the RHS of the question. This is the RHS part of the question. So with the sixth question of exercise 11.4, so we have to simplify secant A into 1 minus sin A into secant A plus tan A. So let's write secant A into 1 minus sin A into secant A plus tan A. So we have to simplify this thing. So first, initially, let's multiply the secant A into the first term. I'll multiply this secant A into the first term. So this would be secant A minus secant A into sin A into secant A plus tan A. We know that secant A is the reciprocal of cos theta. So I would replace this secant A with 1 minus cos A. So this would be 1 minus cos A, and we have this with sin A, and this is secant A plus tan A. We know that sin A by cos A equal to tan A, so the secant A would remain same. This sin A by cos A is equal to tan A into secant A plus tan A, and we have A plus B into A minus B here. A plus B into A minus B is equal to A square minus B square. So we have secant square A minus tan square A, and by properties secant square A minus tan square A equal to 1. And question of exercise 11.4, have to prove that sin A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan square A plus cot square A. So first let's consider LHS side, which is sin A plus cosec A whole square and plus cos A plus secant A whole square. So we're going to expand this thing. So a plus b whole square equal to a square plus b square plus 2a into b. And I'm going to open the second one also, a plus b whole square. So this will be cos square a plus secant square a and plus 2 into cos a into secant a. So we know that. So let's group the both of the terms. So let's group sin square a and cos square a, because we know that sum of this both is equal to 1. Let's keep them aside. And we know that cosecant a is a reciprocal of sine. Let's replace that with reciprocal of sine, which is cosecant a equal to 1 by sin a. And we also know that secant a is reciprocal of cos. So let's replace secant a with 1 by cos a. This will be 1 by cos a. And let's write both of the other terms here, which is cosecant square a plus secant square a. We know that sin square a plus cos square a equal to 1. The sin gets cancelled, cos and cos gets cancelled. So 1 plus 2 plus 2 plus cosecant square a plus secant square a. So this would be 5. And we know that cosecant square a is equal to 1 plus cot square a. We know that uh, cosecant, let's write it again. Sorry. So we know that cosecant square a minus cot square a is equal to 1. Therefore, cosecant square a is equal to 1 plus cot square a. And also we know that secant square a minus tan square a is equal to 1. And if I bring the tan square a to the RHS side, secant square a is equal to 1 plus tan square a. So I'm going to replace this cos square a and secant square a with the substitutions. So this will be, in place of cosecant square a, I'll write 1 plus cot square a, and in place of secant square a, I'm going to write 1 plus tan square a. So this 5 plus 1 would be 7, and 7 plus tan square a plus cot square a. That's it. This is the RHS side of the question. We do 8th question of exercise 11.4. You have to simplify 1 minus cos theta into 1 plus cos theta into 1 plus. So let's write it down. We have 1 minus cos theta into 1 plus cos theta into 1 plus cot square theta. So first, both we have a plus b into a minus b, which is a square minus b square. So this would be 1 square minus cos square theta, and this is 1 plus cot square theta. And yes, 1 minus cos square theta is equal to sin square theta, and cos square theta equal to cosecant square theta. We know that sin and cosecant are reciprocals of each other, and if I substitute square, this would be square theta. The numerator and denominator will get cancelled, and the answer we get is 1. The question of exercise 11.4. If secant theta plus tan theta equal to p, then what is the value of secant theta minus theta? So let's consider the given thing. We have secant theta plus tan theta, which is equal to p. They give. So before that, let's consider, since we have secant theta and tan theta, we know that secant square theta minus tan square theta is equal to 1. And we can write a plus b into a minus b is equal to a square minus b square. Similarly, if we are given a square minus, I can write it as a plus b into a minus b. So secant square theta minus tan square theta can be written as secant theta plus tan theta. This is plus into secant theta minus tan theta, which is equal to 1. And we know that secant theta plus tan theta equal to p, that is given in the question. So p into secant theta minus tan theta is equal to 1. And if I bring the p to the right hand side of the equation, then I would get the answer. That is secant theta minus tan theta is equal to 1 by p. That is the value they told us to find. Last question, that is 10th question of exercise 11.4. And we have to, so let's see if cosecant theta plus cot theta equal to k, then cos theta equal to k square minus 1 by k square plus 1. So this is a big solution. Let's see it. So we have, let's write the question. Cot cosecant theta plus cot theta is equal to this as the first equation. And know the property that cosecant squared theta minus cot squared theta is equal to 1. Similar to the ninth question, I can divide this into two different parts, that is a plus b into a minus b. The given is a square minus b square. So this I can write it as cosecant theta plus cot theta into cosecant theta minus cot theta, that is equal to 1. And we are given the value of cosecant theta plus cot theta is equal to k. So k into cosec theta minus cot theta is equal to 1. If I bring the k to the right hand side, I got the value of cosecant theta minus cot theta, which is equal to 1 by k. Next, I will consider this as the second equation. I want the values of cot and cosecant separately, because if I divide cot theta, if I divide cot theta by cosecant theta, then this cot theta is cos theta by sin theta, and the cosecant theta is 1 by sin theta. This both will get cancelled and the resultant is cos theta. So if I were able to find the values of cot theta and secant theta separately, then I can divide them to find the cos theta, which they told us to find the question. They told us to prove that cos theta equal to something. So we have to find the values of cosecant theta and cot theta separately. So to find cosecant theta and cot theta separately, first let's find cosecant theta. To find cosecant theta, add both the equations, add 2 and 1 first equation. So we have cosecant theta minus cot theta plus cosecant theta plus cot theta is equal to k plus 1 by k. This both will get cancelled. We have 2 into cosec theta is equal to k square plus 1 by k, and cosec theta is equal to k square plus 1 by 2k. I brought that 2 to the right hand side. Let's consider as the third equation. And to find cot theta, let's subtract the second equation 2 from first equation. So second equation is, sorry, let's subtract, okay, let's see the second equation first. So second equation we have cot theta, which is negative. So I will subtract second equation from first equation. So first equation is cosec theta plus cot theta minus cosec theta minus cot theta, which is equal to k minus 1 by k. And if I open the brackets for the second thing, so this would be cosec theta plus cot theta minus cosecant theta plus cot theta. So this both cosecant thetas will get cancelled, and the LCM on the right hand side, which should be k square minus 1 by k, have 2 into cot theta is equal to k square minus 1 by k, and bringing 2 to the right hand side we have cot theta equal to k square minus 1 by k. So let's consider this as the fourth equation. Now we found both cot theta and cosecant theta separately, and to find cos theta we have to divide cot theta and cosecant theta. So let's perform the action. Fourth equation by third equation. So fourth equation we have cot theta, by third equation we have cosecant theta is equal to cot theta is equal to k square minus 1 by 2k, and cosecant theta we have k square plus 1 by 2k, and by after simplification we got this as cos theta. I have explained you before, sorry, cos theta, and this 2k gets cancelled, therefore it is k square minus 1 by k square plus 1. That is the thing they told us to find.